Number 18 says, let f be the function defined by that piecewise function. Which of the following statements about f are true? And then there are three statements about this function. One says that the limit as x approaches 5 exists. Two says f of 5 exists. And three says f of x is continuous at x equals 5. I think it might be easiest to sketch a diagram of the graph of this function, just so you can get a better idea of whether or not these statements should be true. Whenever you try to evaluate a limit, it's always best to try to use direct substitution. If we try to find the limit as x approaches 5, we plug in 5 into x, but you're going to see that that's not really going to work here because we get 0 over 0. However, even though we get something that's undefined here, and that doesn't really help us find the limit explicitly, whenever you get 0 over 0 through direct substitution, more than likely that's going to indicate that we have a hole in the graph. Now, that doesn't mean that's true every time. For instance, if you have an absolute value function, but if it's just a regular old rational function like this, if you get 0 over 0 through direct substitution, that means you have a hole or a removable discontinuity at x equals 5. So we can remove that removable discontinuity by rewriting x squared minus 25 over x minus 5 as x plus 5 times x minus 5 over x minus 5, and watch as the x minus 5s will reduce to 1. Y equals x minus 5 is a linear function, meaning the graph has a y-intercept of 5 and a slope of 1. Essentially, it's going to look something like this. Now, that would just be the rational function itself, but there is a hole that exists at x equals 5, so let's make sure we include that hole in our sketch. That open dot is indicating the function does not have a value there. Now, this is a piecewise function, so when x is 5, we're actually not going to use that function at all, which is good because it's not defined there, but rather we are going to define the function to equal 0. So when x equals 5, y is 0. We've got a point way down here. So now let's go through the different statements and see if we can identify which are true and which are false. One says the limit as x approaches 5 exists. In order for the limit to exist, the left-hand limit has to equal the right-hand limit. And you can see on the graph that the left-hand here limit is 10, and the right-hand limit is also 10. So since the left-hand limit equals the right-hand limit, then the limit exists. F of 5 also exists. In fact, it's explicitly defined in the function itself. F of 5 is 0. So that is true. 3 says f of x is continuous at x equals 5. Now, hopefully you can see on the graph why this is not going to be true, but we can say that it's not true based on the definition of continuity. In order for a function to be continuous at a certain x value, the value of the limit needs to equal the value of the function. Now notice here that the limit as x approaches 5 is 10, but the value of the function is 0. So this is not going to be true. Therefore, the function is not continuous at x equals 5. You can also just tell based on the graph, if there's at any point on the graph where you'd be unable to draw that graph without lifting your pencil, then the function is not continuous there. So because 1 and 2 are the only true statements, our answer is D.